Greetings, everyone. My name is Eric Winford, and I'm a faculty in the University of Idaho in the College of Natural Resources and Range Ecology. And I'm hosting this webinar along with my co-host, Lauren King, Extension Educator in Benoit County. And this is a webinar called Seeds to Success. And it's a monthly webinar series featuring guests each month with different expertise in habitat restoration, landscape management. And for this particular day, we have Brad Stokes, who's going to talk to us about pollinator habitat. And Brad is a Idaho native, born and raised in Boise, and graduated from Capitol High School in the early 2000s. He attended University of Idaho and studied plant sciences, where he graduated in 2008. And then he started his graduate program in 2009 for entomology with Dr. Edward Baczynski. And he studied pea aphid bioeconomics on dry peas and also worked with Professor Sanford Eigenbrod and Dr. James Johnson. Brad completed his program in 2012, earning his master's degree in entomology and excelled in insect identification and taxonomy. After graduation, Brad continued working for the University of Idaho as a teaching and research assistant and taught several classes, including insect identification and for University of Idaho and Washington State University. In the fall of 2015, Brad started a job as with the Idaho State Department of Agriculture as senior agricultural investigator, and then started his career with the University of Idaho Extension in 2016 as an extension educator in Elmore County. Currently, he works with UI Extension in Canyon County and as starting in 2022. So Brad's going to start here in a second, and he'll have about 45 to 50 minutes, I believe, of slides, and then we'll have some time for questions after that. I do want to mention that this meeting is being recorded and that we should have this available on our website. This is a monthly meeting, so our next webinar will be in August. It will be August 28th. These webinars are the fourth Thursday of every month at 11 a.m. Pacific or noon Mountain. And our next webinar will feature Ryan Walker of the Idaho Department of Fish and Game. And he's a habitat biologist at Tex Creek Wildlife Management Area. And he's going to talk to us about rhizomatous grass restoration techniques and wildlife considerations. So register for that and stay tuned for that in August. So I think with that, I'm going to turn it over to Brad. Brad, thanks for joining us here today.
Hey, thank you, Eric, and thank you all the participants. Let me get ready here and we'll get off and running. And today we are going to talk about protecting pollinators in Idaho, the best management practices for restoring pollinator ecosystems. Thank you for the introduction, Eric. My name is Brad Stokes. I'm a U of I Extension Educator in Canyon County. I'm located in Caldwell, Idaho. Right there is my cell number and then my email address below. I run a quite large master gardener program here in Canyon County. We have about 90 master gardeners, and it is a blast. So a little bit more about myself. Yes, I'm in Boise, or I grew up in Boise, went to Capitol, went to U of I twice over. So go Vandals. I excelled in aphids, economic injury levels, economic thresholds, IPM stuff. We did some virus work as well. And I was really good at insect ID and taxonomy. That's where I was really strong. I have been interested in bees and pollinators for a couple years now. I do have extreme ADHD tendencies, so I can go off track if you want me to. Top right is my dog Pepper. He's a mini Aussie. Bottom right is my other mini Aussie, Jack Jack. And then right now, I'm really, really interested in motorcycles. So that's my newest machine. You'll see me riding around here in Southern Idaho if you're in the area. So today we're going to talk about number one, why bees, okay? And then let's talk about the bee species we have here in Idaho. We have quite an abundance of bee species, and I think a lot of people forget that. A lot of people just think of maybe bumblebees, obviously the honeybee, and maybe the alfalfa leaf-cutting bee, but we have a whole host of native bee species. I'm going to talk about what's occurring in Idaho as general, and we'll talk about landscape uses and changes that are coming up. We'll talk about steps and the considerations for ecosystem restoration. For this, I'm kind of scaling this at an acre or more. It's going to take a lot of work if you're going to restore that ecosystem. And we'll talk about helping our bees and pollinators in general, and then we'll have time for questions. This is a fantastic photo of a sweat bee in the genus Agapostamon. It is a male bee. He was out foraging for nectar, so what a great photo though, okay? So quickly, the economics of bees, and I think trying to tie numbers and money to species or ecosystem drivers is really important. So the honeybee value just in the United States, just with our economy in mind, it's going to be more than $34 billion a year, and that's billion with a B. So just that one species is contributing to our economy that vastly and huge. We also have our native and wild bees, right? They're out there pollinating our rare plants, our forest ecosystems, our rangelands, all of that stuff. And I put that value at about $6 billion per year. So that's quite an amazing number. You put both of those together, $40 billion a year just in the bees. And I like to mention the chocolate midge. It is a fly, but we all love chocolate. And without this little fly, we cannot have cacao to make chocolate. And just the value of that little fly is 8.4 billion a year. So you can also research more of this about how bees tie into our economy and why they're so important to not only our economy, but our ecosystems throughout the world, really, right? Bee diversity. We have a lot of species around the world. And I love this graphic on the right because it not only shows the coloration, right? The size, the morphology, all the changes and the diversity of bees in general, right? We have about 25,000 species of bees worldwide, about 4,000 species in North America, and just in Idaho, we're at 720 species. So that is a lot of species of bees. I've broken them down into the families that we see a lot. So we have the apids, that's our honey and bumblebees. Mellidids, these are really rare bees. I've actually never caught one myself. They have a very narrow host range, but they're probably tied to some of those rare plants, rare flowers, rare wildflowers we have out there. Megachilids, these are leaf-cutting bees. These pretty much emerge first in the spring as well, very abundant, okay? The next one is halictids. These are sweat bees. They get that name because they are attracted to the sweat on our skin. Here, these Agapostamon that are bright green are going to be sweat bees. And then we have andrenids. These are ground nesting bees. Something to note about most of these bees is pretty much about 80% of our native bees are going to be in or on that soil profile. So a little bit of bare ground in any ecosystem is a great thing to have for our bees, okay? Bees in our ecosystem, okay? They are amazing creatures, right? What do they do? How do they benefit us? Well, number one, they're providing pollination services. So they're very good facilitators for plant sex with our angiosperm species, right? The biodiversity of the entire ecosystem as a whole, looking at the animals, the plants, and especially those rare plants. Without those pollinator services occurring, those plant species populations are going to decline. Food security and the supply. Okay, so most fruits, vegetables, nuts, bees as a whole are responsible for 1/3 of all the food we consume as humans. So I like this graph at the bottom here. This photo on the left is a normal breakfast, right? Something me and you might enjoy. We got our juice, we got our fruit, our jam, our nuts. If we don't have our pollinators and bees there, this is what our food would look like, right? We just have wind pollinated crops. Fourth, we have our soil health and carbon sequestration, right? They're out there digging their nice little nests in the soil, helping that soil sequester some of that carbon. The regeneration of ecosystems as a whole. I believe that bees and pollinators are ecosystem drivers. Perhaps they're even manipulators, right? If we find a plant that they really like and they like to forage on and it blooms for a long time, they can help facilitate that population explosion in that ecosystem. A little bit about bee anatomy, because we forget what we learn in third grade, right? We'll go to the diagram on the right. The first tagmata of any insect is the head. So for the bee, you have the mandibles. They have a specialized tongue for lapping up that nectar. They have the antennae, and most of the antennae are kind of cool because they have an antennal cleaner for wiping off pollen. They have the compound eyes for visualizing those flowers. They have the simple eyes, these ocelli, just for light to dark ratio. The next tagmata is that thorax. That's all locomotion in the thorax. You got the 2 pairs of wings, so 4 wings total. You got the 6 total legs, right? And most of these bee species will have a pollen basket on that hind leg, and that's where it's going to carry around the pollen. Then we have the abdomen, and lastly, if it's a female bee, it's going to have a stinger. All the males do not have stingers. And this diagram on the left, the forewing and the hind wing, showing this hamuli. This is a wing coupling mechanism so that it helps with flight dynamics for bees and most of the hymenopterans in general. The cool thing about the hamuli is I think this is where they got the idea for Velcro. So if you zoom up real close and enhance that hind wing on any bee, you'll see this row of hamuli that are really neat. So the anatomy is quite extraordinary for the bees. The pollen transferring areas. So I was just talking about most bees are going to have this pollen basket on that hind leg. Now, the other case is a lot of our leafcutter bees or mason bees, they're actually going to have that pollen area on the underside of the abdomen. And you'll see it right here. See how white and full of pollen that is. So as these creatures are flying around, visiting flowers, they're transferring that pollen for plant sex, right? So that's an important thing. Pollination and charges. I think this is kind of cool. Most of the flowers are actually negatively charged. And as the bee is flying around, it's getting positive charges. So there's a little bit of chemistry that goes into this. The other thing is there's a really cool organ right here in the pedicel. It's called the Johnston's organ. It's responsible for electromagnetism detection in the bee. So basically we've got positive charges and negative charges that they attract, the other ones repel. And I threw in some Walter White because I loved Breaking Bad. Okay, quickly about the bee life cycle. Bees are holometabolists. That is, they go through 4 life stages. All bees start as an egg, hatch into a larva, then they go to the pupal stage, and then the adult stage. For honeybees, you have 1 queen per colony unless you get satellite queens going. Most bees are solitary. Some can be social or eusocial. That eusocial is an example of the honeybee where you have an actual caste system. The males are drones, the female is the queen and the workers. The larvae are fed by the workers. As we know, the workers are female, they do all the work. The honeybee queens, they can live for 2 or more years in that honey industry. About 4 years is when they have to requeen. And then workers, they live a really short lifespan as adults in the midsummer. So maybe 5 to 6 weeks, a month and a half. It depends how many flowers they're visiting and how far they're foraging, okay? The solitary bees are a little bit different. They basically have their males emerge first in the spring, then the females. They mate, the males die off, and the females continue for that species. But here's the life cycle. There's the egg, there's the first instar larva, second, then it pupates, and then there's the adult. So kind of cool life cycle. Bee nesting sites. Okay, on the left, I have what we call a classic honeybee, right? It is being managed by humans in a frame, in a box, and that would be the hive. Here in the center, we have our leaf-cutting bees. These are native bees, and they are going to nest in some sort of cavity. Think of a hollow grass stem, a hollow plant stem. They will also nest in wood-boring beetles, right, where they've bored through. So they're going to line this with plant material, and they might have 5 to 6 eggs in that cell, might be a couple inches long. On the right, we have our ground nesting bee example. This is a Pepinapis. It's a squash bee, but it's going in the soil. So it's going to have a main chamber and all these antechambers, and it's going to lay its egg right there and then provision it and cap it off. Okay. The important part about this diagram would be on the right, the soil. This is going to be about 80% of our native bees. Here with the cavity nesting ones, probably about another 18%. And then the actual hive box, really, it's just the one species, that honeybee, okay? Top left, we have our bumblebees. They're nesting on that soil profile. Up north, we'd actually see these nest in mops if they were left outside. I don't know what attracted them to mops. Bottom left is a sweat bee. It's nesting in that soil. Here's some other bees in that soil. So if you see a soil or a hole in the soil, perfectly round, there is a good chance it's a native Idaho bee, okay? So again, 80% of our species are nesting in or on that soil profile. And really, that's about 575 species. That's an amazing number of bee species out there, okay? Bee eyesight. Bees see differently than we do. The top right diagram, this is our human eye. We see from about 400 to about 700. The bees, they see at this UV spectrum. So what we might see in a flower is something like this. The bees might see is this or like that. So the coevolution of these angiosperms and these bees is so specific that they've aligned that coloration and that UV out to say, hey, come to me, come get this nectar, and I'll give you some pollen, okay? So it's pretty cool. Bee foraging. Bees can be generalists or specialists. They can forage up to 4 miles away from their location. That would be like a honeybee. Some people are saying actual bumblebees might go up to 10 miles, so that's amazing. It will depend on their mouth parts. You could essentially divide all the bees into 2 categories, short-tongued bees and the long-tongued bees, okay? The other thing to note, one female honeybee in her entire lifetime of going out there visiting hundreds, thousands of flowers, getting that nectar, she's only really making 1/12 of a teaspoon of honey in her entire lifetime. So just a tiny little drop. And bee foraging, it will be species specific. Some of those Pepinapis bees, they aren't going to go more than like 25 feet because they nest right next to their host plant. Okay. I love this graph. This is from Feldhar and Odie. It's 2020 Insects in Review. And to me, it kind of shows all the stuff that bees are facing out in each ecosystem, right? We have our solution or our source of heavy metals, pesticides, pollution. They're depicted as either these black dots. The pesticides are actually the green dots, right? So with pesticides, you can get a little bit of overspray, some pesticide drift occurring, pesticide runoff, and then anymore because we're using a lot of systemic pesticides. Those pesticides are getting on that soil profile, going down to where they're nesting, and even scarier, they're kind of going up into the plant through the xylem and the phloem. They can end up in the nectar, the pollen themselves, guttation droplets, and this is all the stuff that's really occurring in the ecosystem in one easy to read graph. It's just kind of amazing to look at. Okay. I did a survey. I did a bee survey in 2018, and I repeated it in 2022. I'm still trying to wrap it all up. I caught so many specimens. Just IDing them is a challenge in and of itself. What did I do? So bottom center here, this is me putting up what we call a blue vein trap. It actually catches the bees live. You kind of hang it about 18 inches above the soil profile. That's where they like to forage at. And this blue part, the bee perceives as a big flower. They fly into there and drop, and you can capture them. So I put them on these shepherd hooks. I set them out, and I would leave them for basically 3 days. My parameters and the ecosystems I was trapping in, I did agriculture, rangeland. I had one urban site, which I called Mountain Home, and then I had 3 forest sites. The other parameter that I thought was interesting was the elevation range I had, about 2,300 to about 5,200 feet. And then I had dates, basically an early spring, a midsummer, and a late fall date with a 59-day interval. And the real thought was to, number one, see what bees we have. So that would be the bee diversity, the activity we're having versus those ecosystems, the elevation, and the date. The interesting thing I noted here was that in 2018, I had 2,086 total specimens with 65 species. My friend Dr. Paul Rose helped ID them. And then in 4 years later, I had about half the number of total specimens. I'm still IDing them to date. And it was kind of a fun little study. And I'll show you one preliminary graph here. This was just the bee species composition from my study. So it was huge. It was probably could have been a PhD dissertation at this point. So we had those 4 ecosystems, 12 locations, the elevation, and this was the species composition. And it's quite amazing when you look at it, from bombus to halictus to lasioglossum, andrena, anthophora. So quite a number of cool species that we found. The other thing I wanted to show you, this is the number of individual species on the x-axis versus the trap elevation, okay? The interesting thing about this is it just shows that as you get higher in elevation in any ecosystem, the number of species correlates with that. So if you're at 6,000, you're probably going to get more species. I think there's a couple things factoring into this, but I just think it's something cool to think about, postulate, and consider with bees and ecosystems in general. Okay. The next thing I want to talk about, let's talk about the specific bee genera that are present here in southern Idaho. You'll note that most of these are solitary bee species and gregarious. Gregarious basically means that they're nesting right next to each other because they like that soil profile. Okay, so I've kind of divided them up. We have our desert bees, Diadasia and Melisodes. We have our sweat bees. Agapostamon is probably the most common, that beautiful green, sometimes blue. Lasioglossum and halictus, they're kind of smaller black bees. It really takes a specialist to differentiate those 2 genera. We have our mason bees, which are Osmia. These are really the first to emerge in the spring from what I've seen. Then we have our leafcutter bees. They're in the genus Megachile. Megachile rotunda is that alfalfa leaf cutting bee, which is really, really important for alfalfa seed production. We have our bumblebees. They're in the genus Bombus. We have a lot of species of bumblebees here, and they are going to be social for the bumblebees for the most part. We have our digger bees. They're in the genus Anthophora, a few species here and there. We have our longhorn and our squash bees, Peponapis, really cool bees. And then, of course, we have our honeybees, right? They were introduced in 1622, so I call them naturalized at this point. They are eusocial, and they are managed, right, by humans. So top left, Diadasia right there, Melisodes here in the center with those long antennae. What a beautiful eye on that one. Kind of these stout yellow hairs. Top right, Agapostamon, a really, really easy bee to identify. It's going to typically be this bright color. This is a female. If you see a male, it will have that yellow and black abdomen. Bottom left and the center one, these are Lasioglossum and Halictus. These are sweat bees, very, very common, very speciose here in Idaho. You'll see these all over from your garden to the rangelands to the forest ecosystems. And then bottom right is Osmia. I think Osmia looks like a little boxer. It's got a stout head, a stout thorax. And this one is great because it has a color-coded pollen carrying thing right under its abdomen, okay? So that one you can tell really easily. Top left, Bombus nevadensis. This is going to be our biggest bumblebee, the Nevada bumblebee. You also see Bombus bifarius quite a bit. And then from my experience, Bombus fervidus is going to be the most common, pretty normal sized bumblebee. Bottom left, what beautiful eyes they talk about for Anthophora. I just love those eyes. You can see that long tongue also reaching into that flower to get that nectar. Peponapis, that's that squash bee. It has such a close relationship with cucurbits. It basically is going to nest right under those plants. And then on the right, we have our classic honeybee, and it has the pollen basket right there. So holding some pollen. Okay. We'll talk a little bit more in depth about each of these genera. Diadasia, this is what I would call the desert bees. What cool legs, though, for digging these perfect circles in the hole. That's going to be the nests. So they nest in the soil. They have white hairs. And they really do look like compact bees if you look at them on the side. They are oligolectic, and that means basically that they have this very narrow and specialized host range. So these ones are basically only going to go out and forage and get nectar from mallow, asters, and bindweeds, which is interesting because I've kind of changed my perspective on field bindweed. We can talk about that later. Melisodes, these are apids. They are longhorned bees. And you can kind of tell from this photo on the right that those antennae are long. So that's where it gets its common name. These as well nest in the soil. See that perfect nesting hole. They're more stout with gray or yellow hairs on the thorax and then stripes on the abdomen. These are sexually dimorphic, and most bees are sexually dimorphic. Males have the long antennae, and then the females will have that short antennae, okay? We don't want to skip Agapostamon. Agapostamon, these ones are just absolutely beautiful when you get them in a net. These are sweat bees, that's their common name. They are attracted to our human sweat, so these will land on you, okay? They nest in the soil. They're brightly colored, that metallic green, sometimes this blue-green color. These are polylectic, meaning they are generalist bees. They're out there foraging on any and all flowers that have nectar, okay? So lots of host plants for nectar and a very, very, very good pollinator species. The male or the females are going to be one solid color, this bottom right, and then the males will have that striped abdomen. The males will typically be a little bit smaller as well. Lasioglossum, these are other sweat bees, right? They will nest in soil or rotten logs. It depends on the species. And this is the largest genus of bees worldwide. So about 1,700 species worldwide, probably about 200 here in Idaho alone. They can be polylectic or oligolectic, and they are smaller bees, black in color, and they can have these stripes along the margin of the abdomen. Very good bees, though. Now, Lasioglossum and Halictus, these two are going to be basically impossible to differentiate, but we'll talk about them a little bit. Halictus, these are sweat and sometimes called furrow bees. That would be their common name. They nest in the soil for the most part. The differentiation between this and Lasioglossum is they have different hair on the abdomen, and then there's a particular vein in their wing structure, and it's the basal vein of the forewing that you really have to look at, okay? The species present just in Idaho include Halictus farinosus, Ligatus, tripartitis, and there's a bunch more. But you'll see these on all sorts of flowers, great little bees, and you can see this one coming right out of its nest in the soil. Osmia, I love these bees. These are mason bees. Again, typically first bees to emerge in the spring. They like naturally occurring gaps, okay, cracks or crevices, hollow stems, holes. Again, wood boring beetles, they love those. They have that scopa on the underside of the abdomen, so that's where it's going to carry all the pollen. The picture is color coordinated in this one. I think these are very docile bees. I've actually held these on my thumb. No big deal. They do look like a boxer, and a lot of times they're kind of this halfway metallic color between blue and green. Okay. Bombus, these are the bumblebees. Sociality exists. You have the queen and you have the workers. Weird part about queen versus the workers. The queen is about twice the size of the workers. They are large bees covered in long hairs. They have this yellow, red, orange appearance. They are long-tongued bees, and sometimes they actually can rob for nectar. They are polylactic, so they're feeding on all sorts of stuff, and they will nest on the ground, as we see right there. The nest size for bumblebees is between 50 to 400. And in my experience, you see these in those higher elevations in those forested ecosystems. We also have some parasitic cuckoo bumblebee species. If you find a cuckoo bumblebee, you'll know it because there will be no specialized structure for carrying on the pollen. Bumblebee decline has been well documented in Europe, the US, and Asia as well. So these are species that we need to be very, very cautious of, okay? Digger bees, Anthophora, these are cool bees. I just love that bottom right photograph. That eye is just mesmerizing to me. They're colorful, beautiful eyes, yellow and gray hairs with striped black or white abdomen. And for this species, you'll see this in the rangelands and that forested ecosystems, maybe on the crux of the rangeland and those urban ecosystems as well. Okay, the squash bees, Peponapis. Like I said, a very strong association with cucurbits. So squash, pumpkin, zucchini, watermelon, they're all going to nest right under that plant. Some live in deserts. No surprise, southern Idaho is a desert. They're ground nesting. They're oligolectic, so they only stick with those species, and solitary. At night, you can actually see some of these sleeping in the flower if you want to see that. They're light orange with black, white abdomen. To me, they kind of look like a mutated honeybee, if you will. Okay, maybe a more fuzzy honeybee. This is a cool one. I didn't mention this species earlier. These are potter and or carder bees. The genus is Amphidium. Mostly they're solitary. They are black and yellow with that strong distinction of colors on the abdomen right there. They do make nests in the ground, walls, trees, and they'll go around and they'll actually pluck off the hairs or the trichomes on the plants and use them for nest material. The males have these thorns on the apex of the abdomen for territory defense, and they are very territorial. So if you ever see these out in any ecosystem, you can see them. They'll actually go up to other bees, grab them, and rip them off the flower. So they're really, really interesting and fun to watch. So if you ever see that, it's the genus Amphidium, and you could call them a potter or carder bee. And then lastly, the honeybee, right? We can't do this talk without mentioning honeybees. They were introduced 1622 by settlers. Given the benefits, I consider them native, basically. They're managed, right? They have a whole colony. It's a superorganism. They have cooperative brood care, so that is all the females are taking care of that nest. They have overlapping generations and that strong division of labor where the queen lays eggs, the workers go out and forage for nectar, and the male drones just sit around doing nothing, really, all right? And then lastly, there are other Idaho native bee genera here. This is just a small glimpse of how big the species diversity in Idaho and the Northwest is. We have Sphecodes right here. It kind of looks like a wasp. Ceratina is such a small little bee. People might think it's a speck of dust. Triapiolus, this is a cool one. This is a parasitic one as well. There's Megachile. Tetraloniella, look at those antennae. They're like 1.5 size or times the size of the entire body. Nomata, that is another parasitic bee. Perdita is a really tiny one, and Dialectus is also a very tiny little bee. So we have such a suite of bees here. It's just crazy to me. Okay, so what is happening in Idaho? Well, lots, lots is going on, right? It's probably happening in the Northwest as well. Classically, we used a lot of land for cows, for crops, for rangeland. What I see are some larger landscape scale disruptions or transformations. Whether they're negative or positive, that's not for me to decide. But we're basically taking a lot of acreage and putting down asphalt, concrete, houses, patios, driveways, stuff like that, right? At least here in southern Idaho, where we're growing really rapidly, Canyon County, Ada County, other counties as well, we are taking this land and transforming it into this. Okay. Here is a look at Idaho's population and where we might be in the next 20 years, right? We're really on this huge projected growth, and we are growing at 121%, and the US as a whole is at 39%. So we are greatly outpacing growth, and we basically cannot keep up with it right now. So the implications on ground nesting bees. This is kind of what's going on, and I live in a subdivision like this, where we're taking this native habitat that might have been an alfalfa field, it could be rangeland, it could be another ecosystem, if you will. We're usually taking off about 2 feet of soil right when they start. They're coming in, putting down concrete, asphalt, and then the sad thing is most of these houses, there's almost no angiosperms. There's no nectar resources. There's no flowers for those bees. And then much less the amount of weed barrier that's being put down in rocks. So we're covering up all the soil. And in these photographs, you can basically see there's almost no place for bees to nest in, okay? So we're taking all this land and creating this, right? When you look at something like this in the bottom right, again, there's no color, there's no nectar resources. There's nothing for those bees to forage on, to have energy, to have those sugar and carbohydrates. Whereas even this rangeland photo in southern Idaho, you have artemisia, you have all these plants, the sagebrush, and you have areas where they're all nesting in there. Weed barrier, oh, I see so much weed barrier, so I don't trust the weed barrier at all, okay? The other thing that I see a lot of as an ecologist, if you will, is we're using a lot of soil sterilants at almost every location. And I understand why. They're saying, I don't want any weeds here, so I'm going to use this. The sad thing is a lot of these soil sterilants, I would call biocides. They actually kill everything, and they're being used quite abundantly, all right? So let's get into restoring ecosystems, all right? And we'll talk about some of our guidelines, or what I would consider guidelines. Restoring a big ecosystem, that is a challenge, right? I would say it's too big for one person, okay? So some thoughts here. I want you to be realistic with your expectations. And number one, can you get support from somewhere, someone, some organization? Okay. Be mindful restoring ecosystems takes time, dedication, management, and funds, right? You're going to need some money. I want you to ask yourself, what does your vision or end goal look like? Maybe is there a goal? I want to see this place look like this. Have you set a realistic timeline in place? Keep in mind the key word right there is realistic timeline. All this takes a lot of time. Plant material. That needs to be sourced and selected for properly. Take your time with this step, okay? Keeping in mind the pollinators, the bees, and the native wildlife fauna, okay? Are there resources available for this? And then what about timing? Generally speaking, I would say seeds, right, are going to be our cheapest option. Okay. Then you could do smaller plants, seedlings, and then lastly, establish larger plants for some ecosystems, which would be best for your goal and your realistic timeline if you're thinking 7 years, 3 years. Okay. Can you provide an accessible water source? I say this because bees and pollinators, just like all life forms, they need water, okay? And moreover, the plants that you're going to use going to need some water, okay? The other thing to think about is rangeland, sagebrush steppe, forest, meadow. What's best for your area, right? I can't be here in southern Idaho in the desert and be like, I'm going to have this nice meadow on this plateau. It's not going to work. So be realistic. Top left, I have northern Idaho meadow with grass, lupins. Look at how beautiful that is. Central Idaho, Stanley, you're going to have higher elevation. These are some wildflowers up there, probably arrowleaf balsam root. And then southern Idaho rangeland with flowers and bitter sagebrush. The point in this is that each ecosystem will have a much different climate, both the macroclimate and the microclimate, the biodiversity, the elevation, the season, the nutrient load in that soil profile will play a key role, as well as soil pH. Down here in southern Idaho, we're very alkaline soils, okay? We have different wildlife fauna, we have different plant fauna, and there's a whole host of other things to consider when restoring ecosystems, okay? For me, I would say it's all about timing and resources. You need to research your local plant, wildlife, fauna, if possible. And I would say, actually, not even if possible, you should select the correct and the native plants for your area. For me and for bees or pollinators, try to select perennial flowering plants. That would be the key. Also, I want you to think about invasive plants, animals, insects, pathogens. Is there anything in this ecosystem that has taken over, right? Will you be using an IPM approach, that integrated pest management approach? If so, use your entire toolbox, not just the chemicals, and always consider pesticide resistance. If you have to use pesticides, use them judiciously, okay? Only when warranted. And then last thing, I think this is actually really important too. Do you have the legal authority to restore the area, right? And I underline this one. Always follow all federal, state, county, municipal, and local laws. And then lastly, are there any efforts that are already ongoing that maybe you could join in as far as a volunteer? Top right, I like this story. This is from the Oregonian. This gentleman planted all these larch for this orange coloration. So, and it's Douglas fir around this. And in the fall, these larches turn this color, and it's a great little Halloween thing. So people can transform ecosystems, all right? So remember the schedule as well, as Doc would say back there. Some of their best management practices for pollinators, and then this is just basically pollinators. They have so many challenges that they're being faced by, right? They have a loss of habitat, which is occurring. They have a loss of nesting grounds and that disruption in the soil profile, a loss of native and or host plants, a loss of nectar resources as a whole. You throw in pollution, pesticides. I actually didn't even throw in traffic. Most bees are foraging at that 2 to 3 foot level. So that's where a lot of cars hit them, right? We also have natural pathogens, predators, they might take more advantage of the stresses we're inducing on those species complexes. Okay. And then when considering a restoration, keep in mind we want those native angiosperm plants, and we like to see the nectar resources in bloom throughout the entire season, from early spring to late fall, okay? And that will help our pollinators. This one is really good from Xerces Society, and it's talking about managing natural lands for pollinators. It's a fantastic article, and that's where I got a lot of this information. What a great thing. The other thing you should do before you start trying to modify an ecosystem is see what you have there, right? You want to do a habitat assessment. What is there? Is it acceptable? Is it providing habitat to native Idaho species and pollinators already? For habitat installation, think of good native seeds and plants from a local, regional, reputable supplier, right? Pesticide protection, watch for those neonicotinoids. Those are going to be those systemic insecticides on those seeds themselves. So make sure you get neonic-free seeds, and then the identification and monitoring of that habitat for success. Is it getting better? Is it getting worse? Have I failed in this aspect if I'm doing good here? And a lot of this stuff, I would point a lot of people to that Xerces Society. They are just a fantastic resource. So it's pretty cool stuff, right? A great, great educational resource. And then plant material resources. Where do I go and get stuff to change the ecosystem? Well, there is a whole host of resources out there. So we have the Idaho Native Plant Society, the University of Idaho and Extension Services, Idaho Land Conservation Assistance Network, the Idaho Department of Lands, the Idaho Nursery and Landscape Association, which I work with really closely, the Native Seed Network, Native Plant Finder, so this will help you find those native plants. BLM is good, USDA and the Forest Service is great. ITD is actually great as well, Nature Conservancy. And then I put down here for those Southern Idaho folks, the Snake River Seed Cooperative has a bunch of native seeds, and that's really all they focus on. So just my 5-minute look on Google, I found all of this where you can get relatively cheap seeds or seedlings, all right? The other thing is on campus, we have the U of I Franklin H. Pitkin Nursery. This is a great place to order seedlings. And as you can see, they are quite cheap, right? So for a seedling, we're talking $1.45. That is just incredibly cheap. And if you get them in bulk, they pretty much get chopped in half. So if I was going to do a big ecosystem in a forested area, this is where I would buy my stuff from. I bought them from them before. They're fantastic for tree seedlings. It also supports University of Idaho, faculty and staff, and the employees there are typically students, okay? You can easily order online, and it is very, very, very affordable if you're going to do some landscape restorations. So think of that as well. Planting native seeds and plants, and I'll wrap up in a couple minutes here. For seeds, if I'm going to go out and plant a bunch of seeds in this native ecosystem, it's all about timing. If I had, 200 pounds of seed and I'm going to go and drop it out there, I want to make sure I'm looking at the weather and noting when it's going to rain, right? I'd probably go and sow those right before it rains so you get that water in contact with the seed, and that seed to soil contact is important. You could do this in spring, so I think of April, and then fall for a lot of plants is actually a great time to establish stuff. That seed to soil contact and depth is important. Seed depth is generally 2 times the diameter of the seed. And if you have really tiny seeds, you can just basically scatter them on the soil surface. With seedlings, I like this general rule, right? Don't plant a $100 plant in a $1 hole. You want to make sure that you're digging a proper hole and putting them at their, or in that soil profile at the right level. I see a lot of shrubs, trees here in southern Idaho planted too high or too deep. Make sure if you have that trunk flare that that's going to be your soil profile or soil level, all right? For seedlings, I would say a fall planting is best. Spring can be okay. If you're going to do this and transplant a bunch of seedlings, keep in mind that that really stresses the plant. You're going to have some transplant shock go in. So the idea is to reduce that plant stress as much as possible and perhaps do planting on a cooler day. Okay. The other thing with planting seedlings too, just like the seeds, you want that seed to soil contact. With planting seedlings, you want that root to soil contact, okay? And perhaps a little water to help them get established. All right. The other thing you can do is celebrate the bees and the pollinators. NAPC, which is the North American Pollinator Protection campaign puts on the National Pollinator Appreciation Week. This next year, it's going to be June 22nd through the 28th. So it's a whole week of fun. You can put out tables, showcase the bees. I made some bee salads, some pollinator salads. I had some local honey, some wildflower seeds. So getting that word out and just being visible, whether it's at a farmer's market, a birthday in your backyard, a celebration, let people know that bees and pollinators are important for our ecosystems. And lastly, some ecological ways to benefit bees. I put in here 70, it is almost 80% are ground nesting. So we want to, number one, enhance nectar resources. So a lot of flowering plants, a lot of different colors, and we want them in patches so that they can go out and forage and it can be as a native ecosystem should. We want to embrace that aesthetic of dead things. Remember, that's going to be where our cavity dwelling bees are going to nest. Bare exposed soil between living plants is good. We don't have to have everything covered up, is what I'm saying. Reducing barriers. I would say weed barriers and the like, they inhibit those bees from nesting in that soil profile. Leaving leaf litter. We want to protect beneficial insects and pollinator. And we also know that this adds nutrients over time to that soil profile. So I would say messy is okay. Leaving the soil undisturbed until after May each spring is a good concept. If you can go to no-till operations or not tilling in your garden, I would prefer that. Using pesticides sparingly and judiciously, only as needed for serious pest species. Brush piles are good for bees and other insects. Think of like that native natural habitat. And then lastly, providing that water source, right? We just put a pollinator garden in it at Parma, and we took a bird bath, put rocks in it, and we put some water in there. That way the bees can land on the rock, get a drink of water, and go back to foraging or their nest. Okay? And then lastly, this quote from Albert Einstein. He was quite a genius, right? If the bee disappeared off the surface of the globe, then man and woman would have only 4 years of life left. No more bees, no more pollination, no more plants, no more animals, no more man or woman. All right. So I think that's kind of a powerful quote because really, without the bees, our food supply would drastically be reduced. And then some pollinator resources. These are great ones. I put at the top Xerces. Xerces is a great one for the conservancy of insects. Bee City USA is a great effort, as well as Monarch City USA. We have NAPC right here, the Bee Conservancy, Pollinator Conservation Association, Pollinator Garden Network, and then the Foundation for Food and Agricultural Research. This is Tiff as well. She was in Mount Home when I was over there. We made all these Save the Bee bracelets and handed them out not only to adults, but to youth. And then lastly, a cool project that I kind of try to help when I can is this Idaho Bee Atlas. This is being ran by Carlene Davis. She's a fantastic individual. a great, great volunteer, a smart scientist. And if you want to get into contact with her, this whole effort is to try and identify all the bees throughout Idaho. They're using iNaturalist to do this, as well as capturing the bees. You can get involved with Master Gardener programs locally. And then I would also say Master Naturalist programs are also fantastic. In my mind, all three of these volunteer programs basically have the same goals as far as ecosystem restoration and conservation. Okay. A last thing I would note is I run this fantastic website. It's a great resource for all Idahoans. We call it Idaho Insect Identification. You can take your phone, go out, snap a photo, even a video, send it to us through our specimen submission form. And me, Jason, and Armando might get back to you in 5 minutes or maybe a day or two with identification and a recommendation. Most of the time, actually, we get a lot of beneficial insects, believe it or not. Okay. And with that, I'd like to thank you for hosting me, Eric. I can take questions now. I just want to put up my email address if anyone wants to email me real quick, and I'll stop sharing.
Brad, thank you so much. That was hugely informative.
It's a little much, isn't it?
Oh, it's so much knowledge. Yeah, I'm
Yeah.
like trying to write furiously the how to identify these Bumbus species and the other ones and the sweat bees. It's great. Um, yeah, if anyone has a question, just put it in the Q&A box. There's a little box there. You can type in your question and we'll get that answered. Um, so ask away while we have Brad with us. I just took a look at the Xerces Society website. That is
Oh, so cool.
that's cool. It's got a lot of resources. That's a definitely a neat one and good resource
Oh, yeah.
to help people identify species, understand conservation, and understand some seed sources. Um, yeah, I see no questions yet, but I'm really curious how when you started this insect ID program and how that's been going. Has that been is that kind of an effort to map species across the state? Is that going pretty well for you?
We think of it because me and Jason were the only entomologists at the time in extension, and we were each getting all these emails from all over, and we're going, "Hey, we're doing all this work, and we got no credit for it, right?" So we talked to our bosses, got funding, and it has a map, and we'll probably write a paper or two about it eventually. I think as a number one thing, we can help catch some potential invasive insects in Idaho first. When someone's going, "Oh, that's really weird. I'm going to take a photo and send it to us." So that helps, and then we're creating a big, large database around this, which is really fun. Just
Yeah.
general science.
No, that's great. That's going to be a great resource I can see when you get some information and really, yeah, citizen science, a real way to kind of get people engaged and thinking about it.
Yeah. Any questions? I'm almost at the hour, so
Yeah, just pop open that question box or just send you should have if you have a chat, you can put one in the chat too. Um, but yeah, really appreciate you, Brad. And if people have questions, I think they can reach out to you via your email afterwards.
cool. Thank you, Elizabeth.
Okay, we got one question here. If you have to if you have to use pesticides on invasive plants but want to avoid autumn flowering, is there a timing that would still work on knapweed but not affect native blooms and bees pollinating? Ooh.
Ooh, that's a tough one. As a general rule for a lot of these weeds and the herbicides in particular, right? They are pretty much going to be a lot of auxin analogs, that 2,4-D, that dicamba kind of thing. If you go out and spot spray, and if you can get those weed species when they're just little seedlings, I mean, it's going to just be so much more effective. And that's what I would aim for if I'm going to use a herbicide. Part of an IPM program is still having that box for pesticides when warranted. And I would say that's a warranted effort there.
Yeah, keeping control of some of those invasives like knapweed.
Yeah.
That's a tough one. Um, all right. Well, any other questions, folks? And if not, then please do remember next next month's webinar, the August webinar on August 28th at 11 a.m. Pacific and 12 Mountain, where we have Ryan Walker of Idaho Fish and Game joining us. I'm going to be, this video has been recorded, so I'm hopefully going to put that up on a website soon, and we can send out a link to that if you have any thoughts or any kind of, if you wanted to go back and see anything. But I think we hit our time limit, and I don't have to see any more questions. So again,
Awesome.
thank
Well,
you.
thank you so much, Eric, and thank you all
Dude,
for attending. All right.
that was great. Thanks so much for sharing all your work and great stuff. I'll have to come back and ask you how things are going soon.
All right. I like that. All right, Eric.
All right, well, take care, everyone. Bye.
Okay. Bye.